Now, that's total resistance. How about the resistance per 1,000 feet? Because that is resistance per foot. So I've got 0.024 ohms divided by 224 feet. How did I end up getting two different numbers for that?
Is this A or B?
Yeah.
A.
Yeah. I'm sorry, I got this wrong.
Yeah.
Oh.
Oh.
Yeah. No. My resistance, I was putting the feet in there, that's the next part of the problem. E equals IR. R is equal to E over I, right? Right, so what is my voltage drop allowed? That is the 2% times 240 volts. So that's 0.02 times 240, and what is the current? It's not that, that's amps, 200 amp service. Right. So, I end up with 0.024 ohms. It works out to that exactly. Now I go in here and put it on resistance per 1,000 feet. Okay, great. Skip a step. Don't put, I skipped one unit on here. Look what it cost me. Now let that be a lesson. Write your units down. Jeez almighty. Okay, 0.024 ohms divided by 224 feet. What is the table? It has resistance per 1,000 feet. So if I've got resistance per foot, I multiply by 1,000 feet. And I end up with the grand total of 0.107 ohms per 1,000 feet, which is the table. Now, if I want to go through there and do an aluminum conductor, and what was the first part, underground? Aluminum conductor with an underground feeder that has a resistance less than 0.107 ohms. Which one do I pick? Okay, and what table did you pick on that one? You actually printed out your... Yeah. Yeah, look at that.
Wait, we didn't all do that?
You didn't all print out that? That's a messenger. That's in a raceway or earth directly buried. Okay, so if I take an aluminum one, oh, that's the amperage. Ooh, yeah, we have another.
Yeah, you can just get us a number on the test.
Yeah. See, that's the one that has amperage. You have another one that also has resistance. Yeah. Let's go print that out, Shelby.
Where does the 224 come from?
That's your distance. We actually took this picture. Okay, so if I'm at the residence, wherever that is, and I want to go, well, it's right over here, and I want to go to the main power pole, and there's that, I can actually take that distance on the Y dimension and come up with 224 feet, or I think it was 112 feet.
So what is the 200 foot in the first one? It's amps, it's not foot.
Oh, yeah, screw that up, yeah. See, yeah.
Got it.
Wait, the 224 is the distance from the center?
112 plus 112 is back.
Oh, maybe
Yeah.
you're getting 112 then.
Did we have, here, let me put the picture up. Let's start that. Well, I'm going to put it up here for everybody. Yeah.
First time this thing's been put on.
Okay.
Let's see. Woo-wee. You see where Bill Gates allowed that maybe his choice of control alternate delete was a mistake? I'm like, now you tell us.
Everybody already knows it now.
Yeah, right. My wife is working on a worldwide contract, and some of the funding has come from the Bill and Melinda Gates Foundation. And I laughed. I said, really? She goes, yeah, really. I'm like, well, a little bit of payback for all of the blue screens of death. All the troubles throughout the year, and we finally get a little bit of payback. Well, that's good. Waiting for...
So do we have the right table in the appendix, or?
Yeah, we do. Yeah. She just hadn't printed out the
Print out the whole book. Yeah, we printed out the whole book.
No, I only
Yeah.
printed out the table.
Yeah.
I did not print out the whole book.
All right, I will show you this in just a second. Please, almighty. Yeah.
I've got like everything started over.
Yeah, I didn't print out the
Budget for irrigation.
appendix, that was my fault.
It was terrible. I had 2 binders.
Okay, my work.
Yeah, you put out something, you put out irrigation, didn't you?
Yeah.
God.
I still have it. Everybody's taking irrigation.
All right, there we go, spring, resources.
Could we do that? Could we do the egg motion?
I'm totally off of his question.
Yeah, okay.
Yeah, I don't know. There's a connection between A and B. Did I get A and B wrong, or did I?
No, you had the same mistake on both, so I didn't bother to beat you up
Oh, okay.
twice.
I appreciate it.
Yeah, there you go. Okay, there's that. Here we go. Properties of copper and aluminum conductors. Now, what did I come up with over here? Point. All right. What? Computer on. Yeah, we have a couple of interesting, did a motors program for Disney World a few years ago. Lots of slides sitting on that.
Oh, guess what I met?
Yeah.
The person who hired you.
Who? Wayne
Dr.
Smith?
Yeah.
Where?
He in Costa Rica.
No kidding.
I was with him. I sat next to him like most of the trip.
Wow.
Talked
Awesome
about
dude.
biology and-
Yeah, he always jokes and says, I don't know if it was a good decision or not. Yeah. Yeah, it's not. Yeah, we're good. Anyway, Wayne Smith. Wow. That was a bunch of years ago. Okay. So we figured out it was 0.107 ohms per 1,000 foot we're looking for. We want something less than that. Okay, and we want aluminum. Okay, so if I'm aluminum and less than 0.107, let's see, ohms per 1,000 feet. That's less than 0.107 right there. That's not, this is. You want resistance to be lower than your allowable. Okay, so you pick the next one lower. So that's 0.1 ohm per 1,000 feet, and that is 4/0 aluminum wire. Insulated to barrier. Okay? So, to give a question like this, I'd have to put the table up.
So after HMA is
4/0. Yeah, the right answer is 4/0.
Ooh, nice.
Yeah. Now, if you just went down to the tables and looked at the amperage, you get a totally different number. I got to carry this amperage. That's one answer. But I have to carry that amperage and not have a voltage drop more than 2% over the distance that actually is designed. Because we actually came up with a design. We put that power pole right there, and the residence is that far away, so bingo.
So you want to go lower than what you're actually calculating?
Yeah, you always have to keep track of that electrical. If you're making sure that everything's safe, you want to make sure it's over that. If you want to make sure you have a voltage drop that's less than required, then you have to pick less than. So depending on the question, it's either more than or less than on what you pick. So always pay attention to which way you're looking at it.
So if I picked for the both,
And you're good, but you paid extra money. But you could actually have an economic analysis and say that that extra wire size for that distance causes less of a voltage drop than is on my side of the pole, which means I pay less a utility bill because of that voltage drop on that line.
Let's say, how low below can you
Picked
go?
it because of just an amperage requirement. Yeah.
Pardon? How low can you go below it before you start running into trouble?
You could make a cable this big around. That'd be great. Electricity would love it. They don't care.
So you can do the 1/8.
Pardon? No, you can't go this way. Yeah.
Okay, yeah.
Try to go that.
Okay, it's just not feasible.
Yeah.
we were just thinking ahead.
Right, there you go.
So
So,
you rounded up from the original residence of 160 to the 200?
yeah, because what would you put, what panel would you put there? Yeah. Yeah. We can. No, you can very well think what you did, and I'm sorry we didn't go through that in a little bit more detail, so we got on the right track. So, yeah, you since you all thought of it one way, very solid on my end. Note for next semester. Yeah. Yeah. So that was chapter 5. We'll go over the homework in chapter 6 on Monday, and also any questions on chapter 4. We have a review on what to expect to see on a test. Also, the types of things you need to memorize versus be able to look up.
What's the overhead connector?
That's the other table. Yeah.
With the same numbers, and that one you just take and choose.
Yeah. Yeah.
Hey, where did you say you bury that?
Now you got me confused. I'm going to answer the problem 7 ways to Sunday. Question 6.
Electrician knows all this?
Yeah. See, that's, God, I did it again. I did it myself. Problem 5, you can see that's, I could have marked both problems wrong, and I really didn't feel like doing that. Problem 5 is what we just did, and problem 6 is, now I gotta bury the ground, or hang it over here. Problem 5 would be,
I thought number 5 was you just converting the 160 amps to whatever service you need.
yeah, calculate the main service demand load. Problem 4 is that conversion right there, where you have 160 amps and you end up with what is for the whole farmstead. Problem 5 is,
Right.
what size service entrance would you recommend? And the problem there is the definition of that phrase, service entrance.
Yeah.
The service entrance, if you look back in there, actually means the cable. Right. If you have to pick the cable, yeah. I'll straighten that out on Monday. Yeah.
Prepare to learn before the test.
No. Go back and in particular do example 5.6. Right.
Me neither. I'm the
Oh.
only one that got
112. Okay. I can put that up real quick. We got time.
What example did you say? I'm sorry.
5.6. 5.6. Okay, now we're in chapter 5. And we have a picture. I can't remember what page that picture is. There we go, right there. Okay, see that picture?
That's not the homework though.
I know.
Oh.
Yeah. If I put the main pole here
Yeah.
at 150 and 150, and my house is at 50 and 50,
What is it, 1550?
the house is 50 feet at 50 feet, right? And if I put my main pole, just for example, at 150, 150, I know that that right triangle, that leg is 100 feet, that leg is 100 feet. So the distance is 1.41 times 100, or 141 feet. And that's what we did to get 112. It's a right triangle.
Got it.
You
So
just
you
took,
have to use whatever you.
right.
Center.
Yeah. And that's why it's off slightly. Yeah.
Okay.
That's easy.